In this video, we're going to look at setting up and solving quadratic equations. I'm going to assume that you're fairly comfortable with expanding brackets, collecting like terms, factoring, and using the quadratic equation to solve quadratics. If you're not, please check out the site as there's some key learning material on there. Okay, let's start off. It says the areas of the two triangles on the right are equal. We're asked to write down an equation in x and simplify it. So we've got this triangle here, 2x minus 5 and x plus 4. This one right here, 3x minus 9 and x. Generally speaking, the area of a right angle triangle A is 1/2 base multiplied by height. So if we call this now triangle number 1 and this one triangle number 2, we can say that area 1, and I'll just write it just here, area 1 is going to be 1/2 the base, which is x plus 4, multiplied by the height, which is 2x minus 5. If we look at area number 2, so that's triangle number 2, 1/2 the base, which is x, multiplied by the height of 3x minus 9, which we could factor if we wanted. We could write that as 3 brackets x minus 3. I'm just going to write it now as 3x minus 9. What I can do is say therefore, and using my therefore symbol, 1/2 x plus 4 multiplied by 2x minus 5 will be equal now to 1/2. Then we're going to have x multiplied by 3x minus 9. We can clear the fractions by multiplying both sides by 2, or if you like, dividing both sides by 1/2, and then we'll just go ahead and expand these brackets. So I'm going to get x multiplied by 2x is 2x squared. We're going to get now minus 5x. We will get plus 8x, so plus 8x. Let's just tidy that up. And then we're going to have minus 20. That's going to be equal now to 3x squared. Then we're going to have minus 9x. At this stage, I'm going to set the left-hand side equal to 0. I'm going to subtract 2x squared from both sides, which will leave me 1x squared. This is going to give me plus 3x. I'm going to subtract that from both sides, which is going to give me minus 12x. And finally, I'm going to add 20 to both sides. So that is our equation in the form ax squared plus bx plus c. So the value of a is 1, the value of b is negative 12, and the value of c is positive 20. In part B, we're asked to solve this equation and calculate the area of one of the triangles. If we calculate the area of one, we'll find the area of the other. This looks like it's going to factor. We're going to have now x minus 2, and then we're going to have x minus 10. So we've got x squared, then we're going to have minus 2x minus 10x, which is minus 12x, and then plus 20. So our algebra tells us that x is going to be equal to 2, or x is going to be equal to 10. We must check these. Firstly, if we just look now, if x is equal to 2, 2 times by 2 is 4, minus 5, that's going to give me that this length is negative 1. That can't be the case. Therefore, this is not valid. So not valid, as it gives us a negative length. We can't have a negative length. So if we now say that x is equal to 10, we can go ahead and simply substitute these in. You can choose which one you want. I think this one's going to be easier. We're going to have 10 here. This is going to give me 3 lots of 10, which is 30, minus 9, which is 21. So we can say now that the area is going to be 1/2. We're going to have 10 multiplied by 21, which gives us now 105. So 105 square units. If we put it into this one, 2 times by 10 minus 5 is 15. This would have been 14. 15 times by 14 is 210. Divided by 2, as it's a triangle, will give us 105. So that's what we would end up with, and we knew that they were the same anyway. So when you're setting up these equations, check your solutions are valid. Okay, let's look at another question. In this one, we're told Bill enters a 30-kilometre race. He runs the first 20 kilometres at a speed of x kilometres per hour and the last 10 kilometres at x minus 5 kilometres per hour. His total time for the race was 4 hours. In part A, we're asked to write down an equation in terms of x and solve it. And in part B, it says what are his speeds for the two parts of the run. Okay, let's look at this then. So we've got a speed, distance, time problem. So let's just put up our triangle. So speed, distance, time. and we will look at the information that we need to find. So we've got S, we've got D, and we've got T. We're told that it takes 4 hours. So we know now that we have a time of 4 hours. We've got 30 kilometers in total. So he's running now the first 20 at a speed of X kilometers an hour. For time, we do distance divided by speed. Now we've got the time of 4 hours. So what I can say now is that this is going to be 20 divided by the speed of X, plus the last 10 kilometers, which is going to be 10 divided by the speed, which is X minus 5. So if we look now, the time taken for the first part plus the second part is going to give us now 4 hours in total. So we got 20 over X plus 10 over X minus 5 is equal to 4. We need to solve this equation now. So what we have are algebraic fractions. If you like, at this stage, you could make your work slightly easier and divide both sides of this equation by 2. It's not going to help massively, but it might do in terms of the algebra. This certainly isn't required. So plus 5, all I'm doing is dividing this by 2, X minus 5, and then we're going to have is equal to 2. You can just use this part right here. What I'm going to do now is combine the algebraic fractions on the left hand side. There's a video on the site just here on how to do that, and if you're not sure, please go and check that. Our common denominator is going to be the product of X and X minus 5. So that's the common denominator. I need to multiply this fraction by the X minus 5, so we're going to have 10 lots of X minus 5. I need to multiply this fraction by the X, which is going to give me plus 5X, and that is going to be equal to 2. So if I just tidy the numerator, what we're going to have here now is 10x minus 50 plus 5x, which is going to be 15. We're going to have 15x minus 50. And then in the denominator, we're going to have x, then we're going to have x minus 5, and that's equal to 2. I'm now going to multiply both sides of the equation by the denominator, and that is going to give us on the left 15x minus 50 is equal to 2 lots of x multiplied by x minus 5. I'm going to expand the brackets on the right hand side. So we've got now 2x squared minus 10x. I'm now, from this stage, going to subtract 15x from both sides and add the 50. So we're going to have 0 is equal to 2x squared. We're going to have minus 25x, and then we're going to have plus 50. Again, this looks like it's going to factor. That looks like it's going to factor. What am I going to get on there? 2x minus 5. So factoring, we're going to have 2x minus 5 multiplied by x minus 10. Let's check that works. 2x squared minus 20x minus 5x plus 50. So that works. Again, if you need to learn how to factor quadratics in the form ax squared plus bx plus c is equal to 0, when a is not 1, check out the site here. What we're doing in this video is looking at this part. We're looking at setting up, solving, and then checking our answers are valid and going from there. So if 2x minus 5 is equal to 0, x would be equal to 5 over 2, or we could say 2.5. If x minus 10 is equal to 0, then x would be equal to 10. Again, we must check that these are going to be valid. So if we look at this one right now, the 2.5 cannot be valid. We can't have now on here, assuming this is speed rather than velocity, we can't have now a negative value here. So we can say now that the 2.5 is not going to be valid, so we're looking now at the 10. So x is going to be equal to 10. So let's just write this down. X is equal to 10 as it's not valid for the 2.5. What are its speeds for the two parts of the run? Well, if we look here, the first part was x. So we're going to say first part. So first part is going to be equal to x, which is just 10 kilometers per hour. And then the next one, the second part, what we have now is x minus 5. And we can say second part. So second part now is going to be equal to 5 kilometers an hour. So what we've done is set up that equation, solved it, and then checked for validity. So if we think about this now, 10 for the first part, which is going to take him now on here 2 hours, and then on the next part we've got 10 kilometers at 5 kilometers an hour, which is another 2 hours, which gives him the 4 hours. Okay, let's move on. In this one, we're told a piece of wire is cut into 2 parts. The first part is bent into the shape of a square. The second part is bent into the shape of a rectangle, with one side 4 centimeters long and the other side twice the length of the square's side. So we've got here one side 4 centimeters long and the other twice the length of the square side. Let x represent one side of a square. In part A, we're asked to write down 2 expressions in x for the areas of the 2 shapes. So if we look at this now, we've got the square, so let's draw the square just here, and we have now on here the square, and the side lengths of the square are going to be x. So let's just put this here, so let's write this up, so we're going to have here x. So writing on x, and I'm just going to put x on each of these, let's just put x here, we've got x here, and then we've got x there. With now the rectangle, one side is 4 centimeters long and the other side twice the length of the square side. So make sure you're reading these right, and what I'll do, we don't know what this is going to look like yet, but we'll have something like that. Let's just put that on there. So this doesn't have to be accurate, but a sketch will help. So this is 4 and this is going to be twice the length here, which is 2x. So if we consider now the area of this one is going to be, and I'll just call this shape number 1 and this one number 2, we can say shape 1, the area is going to be x squared. The area of the second one is going to be 2x multiplied by 4, which is 8x. So this gives us now the areas. So that's the first part done. We're asked to write down 2 expressions. So there are expressions, x squared and 8x. If the sum of the 2 areas is 105 centimeters squared, show that x squared plus 8x minus 105 is equal to 0. So we can say now that a1 plus a2 is equal to 105. So we have x squared plus 8x is equal to 105. We subtract 105 from both sides, so x squared plus the 8x minus 105 is going to be equal to 0. And this is a quadratic equation in the form ax squared plus bx plus c is equal to 0. We now need to, in part C, calculate the length of the original wire. So what we need to do is go ahead and solve this equation. That looks like it's going to factor x plus 15 multiplied by x minus 7 is equal to 0. So from this, x would be equal to negative 15, or we would have x is equal to positive 7. X quite clearly can't be equal to negative 15 as it's a length. So x is going to be equal to 7. So what we want is the length of the original wire. So if we look now, the perimeter, and I'll call it P1, the perimeter of the square is 4x, and P2 is going to be on here, we're going to have 2x plus 2x, which is going to be 4x, plus the 4 plus the 4. So we're going to end up with plus 8. So if we take now our value of x, which is going to be 7, we can see that this is going to be 28, and this one is going to be 28 plus 8, which is 36. We need to go ahead and add those together, so we can say that this is going to be 64, and that's centimetres. So all we've done is simply solve for x and then now put it back in and found the perimeter. We need the perimeter as we've got now 4 sides the same, and we've got the 2x plus 4 and 2x plus 4. So that one is all done. Okay, let's go ahead and do one more. In this one, we're told a small rectangular lawn is twice as long as it is wide. It has a path around it which is 2 meters wide. The area of the path is twice the area of the lawn. In part A, it says if the small side of the lawn is x meters, write down the dimensions of the outer edge, the outside edge of the path. With all of these questions, a quick sketch is going to help. So what I'm going to do is just draw now this small rectangle, and then I'm going to put a path around the outside. So what we're going to have is something looking like so. This isn't a brilliant sketch, but hopefully you'll get some idea of what's going on. So what we're going to have then, and I'll put these on, this length right here we're going to have now, and I'll put it on the inside just to avoid cluttering this up. That's x and that's 2x. If we consider now, what we have is a path that is going to be 2 meters. So we're going to have now a 2 meter path, and this of course is 2 meters wide. We just have to be a bit careful here, so let's put this on and it'll look something like this. Okay, so what we've got then, this length right here is going to be 2 meters. This one right here is going to be 2 meters. So that's that length right here. So we're asked now, it says if the smaller side of the lawn is x, write down the dimensions of the outside edge of the path. So this one right here, if we consider now, we're going to have x plus 2 plus 2. This is going to be x plus 4, as we've got these little 2 parts right here. So that's 2 and that's 2, so 2 and 2. So this is x plus 4. This one right here, if we look at this one, this is going to be the 2x plus the 2 plus the 2. This is going to be 2x plus 4. So that now is giving us the outside. So it says if the small side of the lawn is x meters, write down the dimensions of the outside edge of the path. Well, the outside edge of the path is going to be x plus 4 and 2x plus 4. Again, if you wish to factor that, you can do. In part B, it says, by writing down the area of the lawn in terms of x and using the answer to part A, form an equation in x. So let's consider what we're being told here. We're being told that the area of the path is twice the area of the lawn. So if I take 2 lots of the area of the lawn, if we look at the area of the lawn is going to be x multiplied by 2x. If we take 2 lots of this, and just jotting it down, that will be equal now to the path. So if we think about the path, we could find the whole thing, but we need to subtract away the middle bit. So if I just do this clearly, we want the path. Now this is the path right here, and what we're going to do is find that, and there are a few different ways that you could look at this. So I'm going to find now the area of the larger rectangle, but then subtract away the middle bit. So just doing that, what we're going to have then is the x plus 4. So x plus 4 multiplied by the 2x plus 4, and then we're going to minus now the middle bit. So that's going to be x multiplied by 2x. So that is our equation. By writing down the area of the lawn in terms of x and using the answer to part A, form an equation in x. That is what it is. And I'm just thinking if there's a simpler way of doing that. That seems okay though. I'm open to suggestions, but that seems pretty good. In part C, it says simplify this equation so that it can be written as 4 lots of x squared minus 3x minus 4 equals 0, and solve it. Then in the last part, we're asked to write down the dimensions of the lawn. At this stage, if you spot, you might want to divide this equation by 2. If not, just go ahead and multiply it out. X times by 2x is 2x squared, times by 2, 4x squared. If I expand the brackets, we're going to have 2x squared. We're going to have plus 4x, plus 8x, which is plus 12x. Then we're going to have now on here plus 16, and then minus 2x squared. So what we can see from here now is that these are going to cancel. So we have now 4x squared is equal to 12x plus 16. From here, I'm going to now subtract 12x and 16 from both sides. So 4x squared minus 12x minus 16 is equal to 0. Factoring the 4, we've got 4, then we've got x squared minus 3x minus 4 is equal to 0. So we need to solve this. So at this stage, we can divide both sides of the equation by 4 and factor. That's going to give me, that'll factor, that's x minus 4. And then x plus 1 is equal to 0. So all I've done at this stage is divided both sides of the equation by 4 to essentially get rid of this 4 here. So from here, x is equal to 4, or x is equal to negative 1. Clearly, x can't be equal to negative 1. It's a length, so this is not valid. So we can see from here now that x must be equal to 4 based on our algebra. So we need to write down the dimensions of a lawn. Well, what we're going to have then, if x is equal to 4, we're going to have on here, this is going to be x, so this is 4, and this is going to be 8. So we have 4 metres and 8 metres, and that now will give us this area right here, if we wanted, of 32 metres squared. So a more challenging question, and as stated, I think that's probably the quickest way around that part, but I am open to suggestions. So there we go, setting up and solving quadratic equations.